Okay, I'm on page 284, and now we're looking at where it says interpreting parameter changes in linear models. Remember that the two parameters from the previous page that we might change could be the slope or the y-intercept. So let's look at a real-world scenario that could be modeled by linear functions and how, if we change some of the parameters, the line that represents the situation, how that might change. So here we go. It says a gym charges a one-time new member fee of $50 and then a monthly membership fee of $25. The total cost C of being a member of the gym is given by the function C of t. The cost is a function of time, in other words, equals 25t plus 50, where t is the time in months since joining the gym. For each situation described below, sketch a graph using the given graph of C of t equals 25t plus 50 as a reference. Okay, so they're kind of telling you, well, this would be, you could kind of consider that your parent function before you do anything that changes. Okay, so here is your original or your parent function. And let's say the gym decreases its one-time fee for new members. Well, your one-time fee, if you look at the format of the equation, the one-time fee, the $50, is your y-intercept. So if you decrease the one-time fee, maybe you decrease it to, I don't know, $25, then the whole line is going to shift down. The monthly fee of $25 a month stays the same, so the slope's going to stay the same. But you would have a new line with a y-intercept that's at 25 rather than 50. Okay, so for instance, here is the original line, and here would be the new line if they decreased their one-time fee down to $25. Okay. All right, B says the gym increases its monthly membership fee. So again, here's our original situation, and we get a one-time fee of $50, and it's $25 a month in addition to that. Okay, so that's the original one. But if we increase our monthly membership fee, so let's say we increase it to, I don't know, $50 a month, then what we would get is the one-time fee we're not going to change. That's still going to be $50. But then maybe it's $50 a month, which I'm not sure I'd pay for a membership that was $50 a month, but let's just say that that's what we're going to do. So you pay $50 to begin, and then after 1 month, you've paid the $50 initial fee plus 1 month's worth for a total of $100. Another $50 for another month, another $50 for another month, etc. So you could see that increasing the monthly fee is increasing your slope, and that's going to make a steeper line. All right, and then number 5 says, suppose the gym increases its one-time new member fee and decreases its monthly membership fee. So I'm just going to make some numbers up. Let's say that the one-time fee is now, I don't know, a whopping $100. But then you're only going to have to pay $10 a month. So in that case, your cost as a function of time would be 10t plus 100. And I'm going to go ahead and put that one up here as well on the same graph so that you can see. First of all, I've changed my y-intercept, but I've also changed my slope. So my slope is flatter than it used to be, and my y-intercept is higher. So here is where we begin, the $100 membership fee, but then after 1 month, I've only paid another $10. And after 2 months, I've only paid another $10. And after 3 months, I've only paid like another $10. And after 4 months, another $10. And after 5 months, another $10. Okay. Okay, so let's do number 6, and I'm also going to try to draw it on this same graph. I'll just try to pick another color. Once a year, the gym offers a special in which the one-time fee for joining is waived, meaning that your one-time fee becomes $0. Okay, what impact does this special offer have on the graph? Well, now when the one-time fee is waived, we're still going to have $25 a month, but this time plus a $0 one-time fee. So basically, your cost is just going to be the flat $25 a month. Okay. So your y-intercept in this case is 0, and you're going to go up by $25 a month. Okay, so that's the situation with number 6. Okay, so one more time. The black line that they drew is the original situation with the membership, the initial fee, and then the monthly cost. Okay, if we drop the sign-up fee, like we did in number 6, then the whole line shifts down. If we leave the sign-up fee the same, but we increase the monthly cost, then our line keeps the same y-axis as the original, but the line is steeper. And then the light blue line would be like, what if I changed both things? Okay, in this situation, I happened to change it to $100 and then $10 a month, but we could have changed it to something else. All right, here's a little bit more as far as examples about what we're doing when we either change the y-intercept, which is one parameter we could change, or when we change the slope. So these are actually the first 4 exercises in the homework. And it says you're starting off with this function. And for instance, on number 1, it says give 2 more functions in the same family for which the parameter being changed is the y-intercept. So when you are changing the y-intercept, what you're doing is you're taking that line and you are either shifting the line up or you're shifting the line down. So for instance, the green line, f of x is equal to x plus 4, shifts the whole line up 2 units. F of x is equal to x minus 2 shifted the whole line down 4 units, okay, because it was the y-intercept was at plus 2 and now it's at minus 2. Anyway, if all you're doing is you are changing the y-intercept, remember that the slope stays the same and the whole line is just shifted up or down. All right, number 2 says to give 2 more functions in the same family for which the parameter being changed is the slope, m, and the slope is greater than 1. So in this case, we're not changing the y-intercept, okay? So the point where the lines cross the y-axis is going to remain the same. Okay, here's my original line. But if I am changing the slope and m is going to be greater than 1, then what that means is I'm going to make 2 more lines and the slope is going to get steeper. So the purple line is with a slope of 2. The kind of fuchsia or pink line is with the slope of 4. So as the slope increases, that line gets closer and closer to vertical. All right, number 3, more kind of the same. Graph 2 or more functions in the same family for which the parameter being changed is the slope, and it's between 0 and 1 this time. So the slope is a decimal or a fraction. Okay, so again, the black line is the original line, x plus 2. If I do 0.5x plus 2, that's the purple line, so it's not as steep as the original line. 0.25x plus 2 is the kind of pinkish line, and it's even flatter because the slope is even smaller. If I had gone ahead and said 0 was the slope, then we would get a horizontal line. All right, and then number 4 says to graph 2 more functions in the same family for which the parameter being changed is the slope m, and is less than 0. So when m is less than 0, that means it's a negative slope. So originally the slope is positive. First, I just simply make the slope negative. So it was a slope of positive 1. Now it's a slope of negative 1 for the green line. And then I made it a slope of negative 2. So it's still a negative slope, but it's steeper this time. Okay, so that should kind of give you a feel of what they're doing. They're either going to change the slope, which is one parameter, or they can change the y-intercept, which is your other parameter.